presentation. And it did not come from Osaka University. Okay, so the first presenter is Simon Vonlanthen. Sorry for a bad pronunciation. And he's going to talk about use, compositionality, and priors puzzle. Okay, so please.
Yes, thank you very much. Thank you very much for joining my presentation today. And also thank you very much to the organizers for organizing the conference. Unfortunately, this year I couldn't make it in person. As a PhD student, I have limited travel budget, but hopefully I can make it next time in person. So yes, my presentation is titled Use, Compositionality, and Priors Puzzle. And I would like to start, as we often do in philosophy, with a question. Namely, what is the meaning of a decorative sentence? And of course, there are multiple answers in philosophy of language to this question. One big divide here is between use theories of meaning and truth conditional theories of meaning. And usually there's supposed to be some discrepancy between saying, well, it's the use of a sentence versus its truth conditions. And this has led to a very influential line of criticism of use theories of meaning from the truth conditional camp, as it were, and namely that is that they cannot account for subsentential compositionality. So the way that subsentential expressions combine to form meaningful wholes. Now, this raises a number of questions that I would like to tackle in today's presentation. First of all, is that actually true? Does that hold? Can they account for this phenomenon? And since this charge is coming from the truth conditional formal semantics group, the question is, what role does compositionality play there? And relatedly, what role should compositionality play in use theoretic approaches? And ultimately, my answers here will yield a sort of division of labor between these approaches. I don't think they're trying to tackle the same phenomenon, and then therefore there might not be any competition here. And the combination of these approaches will also allow us to solve certain problems, such as I'm going to talk about it today, priors puzzle at the end. My program is very straightforward. I just want to quickly start with talking about using compositionality and answering this charge about use theories not being able to accommodate compositionality. I will then talk about the role compositionality has in formal semantics before trying to tackle at least the aforementioned priors puzzle, and then of course a conclusion at the end. All right, use and compositionality. Use theories, just some very quick basics, and of course I have to be very quick here. But use theories in general just want to analyze the concept of meaning. And they usually do this by drawing on some notion of use. This can be done metasemantically, as trying to answer the question, why does an expression have the meaning it has? And it can also be understood semantically as the thesis that, yes, indeed, the meaning of an expression just is its use. And usually then this is understood as patterns of speaker behavior or conventions that govern the correct use of a word, etc., etc. Inferentialism now, as a more, let's say, contemporary and popular alternative, is a species of use theories that do equate use with inferences, specifically their propriety. And usually inferentialists use some sort of assertibilist semantics, so they tend to eschew truth conditional semantics. Not all of them, of course, but most of them I think do. And the very important point here is that they treat sentence meanings as semantically primitive. So the semantic unit for the inferentialist is the meaning of a sentence. Of course, standard example here from logic, where this sort of approach is very conducive. And the idea here being that the meaning of conjunction is constituted by these introduction and elimination rules, as we usually find them in natural deduction systems. Now, I think there are two important caveats I want to mention here. First of all, inferentialism is sort of a mislabel, and I think that has been conceded by inferentialists by now, definitely by Peregrine. Namely, inferentialists study rules that go from things other than two propositions. So we have rules that study the quote-unquote inference from a proposition to an action, for example, and so we ordinarily call it an inference. So it would really just be called rule-based semantics. Also, based on my own work, there is indeed the possibility to combine this sort of inferentialist approach with truth conditional semantics that I have worked on myself. I'm not going to go into the details too much here. I will assume this from here on out, the feasibility of this approach, and I will show an example later, but it's not technically necessary for my argument. All right, so the overall picture then here, according to the use theorist, especially the modest inferentialist, looks like this. On the metasemantic level, you have some sort of ordinary use of words as given by the linguistic community, which sanctions and disallows certain uses of words. This gives rise to rules that govern expressions, and specifically that term distinguishes between correct and incorrect uses of words. And then important for me at least, and certain other inferentialists, is also that these rules determine semantic values, such as truth conditional contribution, reference, truth values of sentences, etc., etc. This is the overall picture. Now, compositionality, I'm sure everybody here is well acquainted with this. The meaning of a complex expression is a function of the meanings of its parts and the way they're combined, specifically syntactically. And of course, this is supposed to explain the productivity and systematicity of language. It might actually even be the only, not just the best, but probably the only explanation for this. And of course, I don't think it can be overstated how important this is as a research paradigm in contemporary homosemantics. But now the problem here with compositionality is, of course, that it kind of clashes with this sentence-first approach that inferentialists tend to use. That's an argument due to Porter and Lepore. In a nutshell, it goes like this. So in order to account for compositionality, the meanings of subsentential expressions specifically have to be able to be composed in some way. But then the problem starts because the rules of inference that inferentialists like to draw upon, of course, do not operate on subsentential expressions. They operate on whole sentences. And even if you then equate the meaning of an expression with some set of rules, then of course those neither can really be composed in the way required. Therefore, we cannot account for compositionality. Now, technically, and this is a path that has been chosen by some use theorists, is of course to argue against the centrality of compositionality. I'm not going to do this here. I would generally agree that compositionality is a very widespread and pervasive phenomenon. So I'm just considering now the answers that say, okay, we do want to accommodate compositionality in some way. Now, inferentialists themselves like to go the route of decomposition, as I like to call it. The idea being that the rules themselves do give you the sentence meaning. Usually this is some sort of assertion potential. And the idea is then to decompose the assertion potential as according to the syntactic structure. And sort of endow subsentential expressions with sentence meaning contributions in this way. Now, there are some issues with this, and for reasons that continue to elude me to this day, Peregrine especially is very insistent on this decomposition being indeterminate, in the sense that there are equally differently valid ways of carving up sentence content in this way. I'm not sure why he's so insistent on this, but it clearly doesn't hold. If you look at a sentence like Peter snores, there are not that many ways to decompose this sentence. And I also, very importantly, I don't think we would say meaning of Peter changes just because it features in other syntactic constructions. So if Peter makes a very unique contribution here, as it sort of has to, because there are no other ways of carving up this content, then it does in other occurrences. And this, of course, generalizes to other expressions. Not all of them, maybe, but I think most of the expressions in natural English do work like this. And of course, there's another problem, namely that we mainly speak about the meaning of words and explain the meaning of words, and we don't do sentences as much. So Glock thinks that there's a bit of a weirdness to the sentence-first approach in general. Hacker and Glock and other kinds of more traditionally Wittgensteinian or orient philosophers then have just rejected the sentence-first principle and say, no, we want our rules to operate on subsentential expressions and not on sentences. So Glock gives the following example: for all x, it is correct to apply Drake to x, just in case it is a male duck. However, Glock also is very insistent on rules having to already feature the different syntactic combinatorial possibilities. But then the rule that he gives us is this one. So the issue here is that it's exactly not clear how we get from the correctness of applying Drake to making true statements, much less how Drake is to be composed or combined with other expressions. So here is my own solution, which is very much in the spirit of what Glock in his 2019 paper has written. But generally now, under the modest inferentialist proposal, like the sort of inferential network of Drake looks, at least part of it looks like this. And we have, again, this classical distinction between introduction and elimination rule. However, the way I read this now is that generally there's a presupposition that X is a reverse, but that basically the introduction rule tells us the sufficient conditions for the truth of a statement, whereas the elimination rules tell us about the necessary conditions. And here, of course, they're both featuring on both sides, so therefore we have a classical if and only if condition from this. So the rules here have a dual role, really. So they do specify the meaning of a word. I mean, those rules are very ostensibly about Drake, but they do so in the context of a sentence. So they are now truly really featuring already the way Drake is supposed to be combined, at least in certain atomic cases now, in the context of a sentence. And I think the general take-home message here is that the rules are inherently schematic, otherwise they wouldn't be called rules. And so in the case specifically of semantic rules, we do have to specify already the syntactic combinatorial possibilities of an expression, and they will already feature. And in case that an expression changes its meaning depending on the construction it is placed in, then of course we would have to consider different, like the set of rules just has to be in these cases. So meaning remains constituted by rules under this approach, but it does allow for sort of an excavation of truth conditional contributions for its substantial parts in a compositional, because schematic way. All right, this so far my solution to the Fodor and Lepore argument. Now about compositionality. And here I envision a sort of division of. So on the one hand, use theories of meaning, given their philosophical motivations, are really geared or designed to elucidate conceptual content. I think this is really their main business, and they usually do so by studying the correctness. Correct here meaning roughly a use that would render a statement true or false, you know. Though of course there is a lot of debate about what correctness ultimately amounts to. In contrast, formal semantics tries to capture the compositional structure of natural languages by means of mathematical methods. So use theorists don't do a lot of formal semantics, I think, as is well known. And here instead, the focus is very much on providing precise mathematical methods for compositional structure of a sentence. So if we compare this, I ignore the issue of what the meaning of a proper name like Peter is at the end of the day. Well, whatever it is clearly one of the functions is to pick out people. And so here, the truth conditions, according to the modest inferentialist proposal, roughly would look something like this. Peter is a Drake is used to say something true just in case Peter picks out a contextually salient object, which is both a duck and a male. And if you look at, and this is of course a simplified example from intentional semantics now, if you look at the similar truth conditional account from formal semantics, it looks like this. And clearly, one tells us something of what it means to be a Drake, whereas two does not. But however, two does very clearly and very precisely state how Drake is supposed to combine with other expressions to form a true claim, to ultimately yield a true claim. Now, what are the reasons to adopt this picture? So first of all, I think it's quite clear, two is very uninformative. So this doesn't really tell me anything about Drake, and it can't be used to teach the meaning of the word Drake to somebody, but it does account for its compositionality. I think that's quite clear. By that token, as Hacker points out, this is not an analysis of the meaning of Drake, obviously, since I can't use this to teach somebody the meaning of Drake, but meaning is the kind of thing that can be taught and explained to other people. And indeed, it is hard now to see how model theoretic tools could actually achieve that, because ordinary speakers don't deal with model theory trivially in that sense. Also, it explains the equivalence results that we have about different type systems. So as is well known, different type systems can generally be translated into each other. There's a certain morphisms between these. And indeed, if the goal of formal semantics is to account for the compositional structure of sentences, then of course, we should not be surprised about this because structures are a unique optimizer. So different type systems can do the job equally well. And I think at the end of the day, it all just very well coheres with the actual research practices and aims that we find in contemporary formal semantics research. Now, I want to quickly discuss a potential objection to this view, which is, well, what about entailment relations? Clearly, in formal semantics, we also want to explain entailment relations. Specifically, for example, those so-called diamond entailments from John buttered the toast at midnight to John buttered the toast. And so now the objection would go, well, the standard explanation here goes in terms of event semantics, and those are not. So not only is it not about trying to derive some positional structures of a sentence alone, it's about an entailment, and moreover, the received explanation is not really compositional on a subsentential level. Quick reply to this. First of all, it can be made compositional. So Chapolian has worked on this to make the sort of event semantics compositional on a subsentential level. Moreover, I think it's quite clear on a pre-theoretic level that this inference is clearly a structural one. We're just splicing away part of a sentence or part of a proposition. And so it would seem to me that at least they're compositional on a sentential level. Indeed, by the Neo-Davidson event semantics approach, this is just conjunction elimination. This is not exactly a conceptual inference in this sense. And of course, even if the culprit is located with buttered as an event verb, requiring aspects, for example, there's still a difference between drawing on lexical semantics and practicing it. And there's also a big difference between doing conceptual analysis and lexical semantics, though unfortunately, this would be a talk in and of itself. If you are interested in the difference, let me know in the Q&A. So let me finish now with talking quickly about Prior's puzzle. So the puzzle in a nutshell is that, in general, this is at least the original version. I cannot substitute proposition into propositional attitude reports. In general, X v stat P is not equivalent to X v the proposition that P. So, for example, X knows that P, at least from a use theoretic perspective, means as much as when somebody is aware of the fact that P, whereas X knows O, with O being some DP, means as much as X is acquainted with this specific object. So this clearly doesn't mean the same thing. And as we also know, this sort of generalizes to a larger set of substitution phenomena, such as in Sally seeks a unicorn versus Sally seeks the generalized quantifier denoted by a unicorn. Clearly, this is not the same thing, or does not mean the same thing. So, coming from what we have done so far, there are two key observations. First of all, in ordinary language, proposition, it has to be pointed out, does not mean declarative sentence content. That's not how ordinary language proposition is used. Rather, it means as much as offer, recommendation, or plan of action. Like I have a proposition for you, and that sort of use. Yes, it can be found, I think, in mathematics textbooks, but that's the only place where people mean claim by proposition. And so this is the first thing to notice, is that we're kind of dealing with a confusion of technical and ordinary vocabulary. Second, the Hintika style analysis that, of course, is presupposed in Prior's puzzle, now according to the perspective on formal semantics I'm advocating, was never an analysis of propositional attitudes to begin with, but it was simply a compositional account of such reports. It's a relation to the proposition in the sense that the content of the that clause obviously modifies the content of the overall statement. but it is not that believing or knowing things is indeed a matter of a relation to an abstract proposition or something like this. And so literal interpretations in this sense are a non-starter. All right, now, so we can now see that the puzzle arises due to an impossible standard. On the one hand, formal semantics should analyze the meanings of expressions, in this case of verbs like propositional attitude verbs, but what it really does is just provide mathematical models of compositional structures, and so the substitutions could never have succeeded. So therefore, first of all, this is not a threat to formal semantics contra people like Hacker, as long as we understand the goals of formal semantics correctly, and I will be done in a few seconds, don't worry, I'm almost done. And so this puzzle does not require a technical solution, but should rather just be abandoned, because the presuppositions are just not cannot be met. And I think as long as this is clarified, the puzzle can be rejected. All right, conclusion now. So in this talk, I have surveyed existing solutions to arguments from compositionality against use theories and found them wanting, and then provided my own, given my own framework. I presented an account of formal semantics as compositional semantics, and also tried to sort of deflate a bit the tension between use theoretic and truth conditional formal approaches, and then use the resulting account to solve, or at least try to dissolve rather Pryor's puzzle. All right, and with this I'm through. Thank you very, very much for your attention. I will be happy to hear your questions now.
Thank you very much. So we'd like to have your comments or questions. So do you have, okay. Oh, questions in, okay, thank you. So we have a question in the Zoom participant. So Julie, could you go?
Yeah, hi. Thank you so much for the talk. That was very interesting as far as I can kind of grasp it. My question is about what I'm trying to connect your story with is Robert Staunhofer's view that we can try to solve the problem with equivalence in his system by distinguishing that the problem arises with mathematical truths. And what he does is that he tries to distinguish the sentence, let's say 2 + 2 = 4, and the proposition 2 + 2 = 4. And that kind of helps him to amend his story. So what I'm trying to, it seems to me that in reasoning, we do want to try to distinguish between those two propositions. The one proposition is 2 + 2 = 4, which is a mathematical truth. And the second proposition is the sentence 2 + 2 = 4. So it seems that we want this layer as well. As far as I understood your story, that you will not have this access to this, I don't know, metalinguistic or whatever level, or how would you kind of, what do you think about that?
So yes, I don't think there's a direct way to the metalinguistic level here in my case, but when it comes to, I mean, this is one of the very few exceptions where proposition is indeed substitutable into these reports. Like, for example, Peter proves the proposition that 2 + 2 = 4 versus Peter proves that 2 + 2 = 4. But it is actually predicted here because proposition in the context of mathematics does indeed mean, you know, the mathematical statement, as opposed to ordinary language in otherwise, you know, where knowing a proposition and knowing that P is not going to be the same thing. So here, indeed, it is the same thing because proposition is used in a way that denotes the same thing. So this is, I thought about mathematics as well. And I think the reason why it works there is precisely because proposition there is already used in a way that denotes propositions in our sense, in the sense of semantics.
Yeah, well, yeah, but then do we have access to all? This will make a problem that we have access to the proposition once we have access to mathematical truth, once we understand the sentence of the mathematical truth. meaning that if the 2 + 2 is easy, but if we have something like, I know, Fermat theorem or whatever very obscure mathematical proposition, then we can have access to the sentence P, but not the P itself. So how would you, there is no equivalent between those two. You see what I'm trying to ask?
Yeah, I mean, I'm not sure if I would agree though. What do you mean exactly by we have access to the sentence but not the proposition? Like the people might understand the sentence but not understand what is being expressed by it, or yeah.
Okay, I see. Thank you.
Yeah. I mean, I would doubt that. I think if you actually understand what it, like if you understand a sentence, then you know what it expresses, right?
In mathematical truths as well as in ordinary language.
Yeah, I would say.
Okay.
Yeah.
Okay, I see. Okay, thank you.
You're welcome. Thank you very much for the question.
Thank you. So, another question? Comments? Yeah, please come here and over there, so that you can. Yeah. Yeah, please. Talk to. Oh, good. The camera. Yeah. Thank you very much for your talk. I think I kind of managed to grasp the first part of your talk, but I got a little bit confused where the prior's puzzle entry. What was the? Could you please explain the role of the prior in the talk?
Sorry, could you please repeat this? I didn't hear this acoustically.
Okay.
Like, you want me to like quickly summarize the solution to Prior's puzzle? Or? Yes.
No, if you just explain maybe again what was the role of the Prior's paradox in your talk. I didn't really manage to understand where exactly it fits.
Yeah. Thank you.
Yeah.
So the idea of discussing Prior's puzzle is twofold, really. On the one hand, I think it's just a nice demonstration that once the sort of like the proper aim of formal semantics and the way that these things are done is clarified, we realize that this puzzle is not a puzzle anymore, because it sets like it presupposes some things that just aren't met by a proper understanding of the aims of semantics, or formal semantics, that is. That's on the one hand, but on the other hand, the thing is also coming myself from the more use theoretic literature. There is actually Prior's puzzle. They don't call it Prior's puzzle, but that's one of their standard arguments against the Hintika style analysis of propositional attitude reports. They point out, look, fearing that P and fearing proposition that P is clearly not the same thing. In fact, I have no idea what the latter is even supposed to mean. Therefore, but also since what X fears, can be what A believes, what B knows, what D hopes, like, because all of these things are the same thing, or content-wise, the same contents, then if fearing is not a relation to a proposition, then neither can all these other attitude verbs be a relation to a proposition. And then they believe that this is sort of like a decisive blow against the more formal accounts that we find in truth conditional semantics. And I don't think this argument works. Again, since, yes, I mean, I think they are right to point out that believing something is not a relation to a proposition, now literally speaking. This is not how we ascribe beliefs to each other. I don't need to check if somebody has a certain relation to an abstract entity in order to be entitled to say, oh yeah, they believe that P. This is not how it works in ordinary language. So this is not what that means. However, of course, the whole relational analysis is just supposed to be an account of how the that clause combined with the matrix work to yield a claim. And I think in this sense, it is absolutely fine to call this a relational analysis, because indeed the content of the that clause is very, very important for determining what is being believed at the end of the day. So I'm trying to mediate a little bit between both camps here, right? On the one hand, help formal semanticists by solving Prior's puzzle. And on the other hand, also staving off a little bit those, I believe, rather uncritical appraisals or unreflected appraisals of formal semantics by some of the use theorists that you find in the literature.
Yeah, thank you very much. It was much more clear.
Thank you.
Thank you. So any other questions? We could have a very quick question, one more quick question. Otherwise, maybe we should end here. Okay, Simon, thank you very much for your talk. Okay,
Yeah.
let's start
Thank
here.